How vegetation shifted in the past 10,000 years in Minnesota. The blue line here shows the boundary between the pine-dominated system to the northeast and the oak-elm to the southwest. This is about not far from the Minnesota Valley, River Valley today. So pine 10,000 years ago, 90,000 years ago, was much farther south and west than it is today. Just in 2,000 years, and with natural climate change, it moved much further back to the north and east. The blue line showing the boundary with pine and oak prairie systems, and has migrated since then as well. So species moved in the past in climate change, and they will do so again. That's just an inevitable part of nature. Now, climate change has direct effects, but has many indirect effects, particularly in our part of the world, through changing fire regimes. And the boreal forest is molded historically by periodic crown fires such as this, which have given us the range of vegetation we have, including our mature white pine forest and red pine forest. And how many in this room actually knew Bud Heinzman? It has to be a few. Oh, quite a few. That's great. Well, he was a fabulous researcher who went around figuring out what was the fire history and the vegetation history of this region. And I'm going to show a series of overlays from his data showing fires in different time periods in the past. It gives us a visual understanding of just how dynamic this area is. So this shows the areas that burned in the BWCA, what's now the BWCA, in the 1600s. This is the early 1700s, different colors each time. Mid-1700s, 1780s and 90s, 1800 aughts, 1815 to 27, 34 to 54, 1863 to 64. A big fire year, I'll go back. This is the before, and then 1863 64 is a very big fire year. 1870s, 1880s, 1894, 1900, 1911. Oops, so that's it. And I should mention, it's not there were no fires here, you just didn't study here. So I see in this mosaic of fires in the past, we realize any one piece of the landscape might have been burned once in a few hundred years, twice, 3 or 4 times, because lightning and configuration of vegetation was such that fire was a repeated visitor to this landscape. So fire is a very integral part of what goes on in this boreal forest, and will continue to be in the future as well. And as you all know from the work of Bud Heinzman and others, fire favored pines. Different kinds of fire favored jack pine than white pine or red pine, but they're all fire dependent. And aspen and birch also are favored by fire. But the heterogeneity of fire in time and space also promoted spruce, fir, and cedar on the landscape in areas that were protected from fire or didn't burn as often. So that created a mosaic, a very complex landscape. Given that we have only 10 or 12 tree species, it's still a very, very diverse area given the small number of trees. And of course, European settlers came in, and starting with horses and handsaws in the 120 years ago or so, and up to machine logging in the current era, we logged almost all of northern Minnesota. Forests were cut, massive fires followed, and then after 1920, fire was suppressed. So it went from a fire-dominated system to one dominated by logging. And the net result was landscape shifted to aspen, and also more recently, perhaps increasingly, to red maple. And here's just one kind of data figure that shows this. Steve Friedman, a student of mine, and I published a paper a few years back using historical records from the government to look at the change in each of our dominant species. This is just white pine. Each of these squares is a 6 by 6 mile area in the arrowhead. There was no data. The Forest Service didn't collect recent data in the boundary waters until a few years ago, so we weren't able to look at that in this context. But for the rest of the boundary water, the rest of the arrowhead, you can see the white pine was variably abundant in the 1890s, with lots of yellow and red squares showing where it was more than 15% of the wood, the basal area, very patchy. And by 1990, as a consequence of timber harvest and fire suppression, it was very, very sparse, less than 2% in almost all areas, a few places where it was 5% or so. And of course, we know aspen has increased in abundance, and many other species have decline as well. So we've changed the landscape by our changing of disturbance, by logging and then suppressing fire. So we've already changed this landscape a great deal. And that leads us up to last decade. 1999, there was the big blowdown. Map from the Forest Service of the the trajectory of the storm. How many of you were here on July 4th, 1999? Okay, well, how many were actually here versus over in the western part of the boundary where it blew down mostly? So a few people experienced that. Just a couple of pictures remind us of what that looked like. It's changed a lot in the last 11 years. And one of our former PhD students who's currently working as a postdoc with us, Reich, did the very ambitious study of setting up 739 plots in the Siegel Lake and Alpine Lake area at the end of the Gunflint to try to characterize what the windstorm had done to the landscape, what the implications would be for the future forest. We've always had windstorms, but they're historically rare in this part of the forest. Much more common in Tornado Alley down in Oklahoma and places like that. With climate change, the climate scientists are predicting that wind will become a more major, more frequent disturbance agent in the southern boreal zone. Now, we have no way of knowing if this particular windstorm actually represents climate change or not, just like we can't tell whether any hurricane by itself represents global climate change. But the climate projections are for more wind disturbance in this part of the world. This is actually the most challenging fieldwork I've ever seen anywhere. These are a couple of our undergraduate assistants that year. Their feet are actually about 7 feet off the ground. They're standing this entire summer. People were walking on the tangled mat of downed trees. I was very, very happy no one broke an ankle or leg that summer. Very easy to do. So very, very challenging to get around and set up these 740 plots. Picture before and after the blowdown in 1999. And the take-home message from what wind does to the forest is that it selectively weeds certain species from the forest. And Roy would kill me if he knew I was summarizing an entire dissertation into, what is it, 7 or 8 words. That's what science is like. A lot of work to find out some simple things. I'll only show you a couple of complicated graphs today, or pieces of science. But I want to show you a couple, both to convince you who actually did the research and to share a little bit of data with you. This shows the mortality probability. If 100% of the trees died, it would be 1. If none died, it would be 0. This is from the windstorm across all of the sites. And this is for 7 or 8 species. Every species, not surprisingly, bigger trees were more likely to blow down because their crowns are higher up. Some different shapes of the curve. But jack pine, aspen, and red pine were the 3 species that are most vulnerable. Basically, for jack pine, between 60 and 80% of the trees blew down, regardless of the size. Red pine was mostly large trees that blew down a lot. Aspen is quite sensitive as well. In contrast, the species that were least likely to blow down are birch and cedar. About 10 to 20% of those trees blew down. So the different characteristics, birch is very flexible, cedar is very strong, so they use different mechanisms to do it. But in the same landscape, then, species like jack pine and aspen have become sparser because they blew down, whereas residual cedars and birches tended to be more likely to stick around. Spruce and fir had a very different pattern, where small trees, 4 or 5 inches or so, were not likely to blow down, but 12-inch diameter spruce and fir were quite likely to blow down. So their younger spruce and fir likely survived, but older ones didn't. Now, so these different mortality patterns created a complex, and I'm not going to walk you through this, complex change dynamic in the landscape that I'll summarize this way instead. That windstorm favored birch, spruce fir, cedar, and red maple because either they were not likely to blow down or they were present in large numbers of small sizes. So spruce and fir, even though large ones blew down, there were many, many spruce fir that were short. So they were liberated, so to speak, from competition when the big trees fell over. And so the mechanisms are that the windstorm blows down the big trees, leaving the resilient canopy trees like cedar, and releases understory trees such as spruce and fir. And so wind does something very different than wildfire in terms of molding the future forest. But, as any of you who